T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. 30 minutes after the hour.
Mission Control, we have liftoff.
Welcome, everybody, to another exciting episode of What's Up with the Universe. I am your host, Eli Hugh. Yes, like I stated, we are touring the solar system. Today, we are going to do Uranus, Neptune, and outer Kuiper belts. Yes. I'm not a proctologist. Like I said, I'm not doing Uranus, okay? First place on our journey here, we are going to, like I said, Uranus. See, Uranus, it's the 7th planet from the sun right now. It's the 3rd largest radius of all the planets out there. It does have 13 faint rings and 27 small moons, yes. But you can see it sets apart from every other planet in the solar system right now because you can see there's some clouds in here. Yes, it does have clouds. It's so large out, it takes about 84 years to orbit the sun. I mean, Uranus is about 4 times wider than Earth. If Earth was large, like an apple, as you can see on the bottom right there, Earth would be the size of a little basketball. Yeah. In case you were wondering this, Uranus, it was discovered in 1781 by William Herschel. It was the first planet found using a telescope. Every other planetary body you can see with your naked eye, even Saturn and Jupiter. It is an ice giant planet, nearly 4 times larger than Earth, as I said. Like the other ring planets in the solar system, Saturn, Jupiter, Neptune, Uranus has a ring system. It takes about 17 hours or so for Uranus to rotate once a day, and about 84 Earth years to complete a whole entire orbit around the sun. The picture right here was taken by Voyager 2 through 3 color filters. And it was recombined to produce this image right here. As you can see, another infrared object here taken by the Keck Telescope Advanced Optics. The Keck Telescope, I can't even talk today. The Keck Telescope is located in Hawaii. This is an infrared composition image of the 2 hemispheres of Uranus. You can see the North Pole is at 4 o'clock on the picture. You picture a clock, 12 o'clock, 1 o'clock, sorry. 12 o'clock, 1 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. It's at the 4 o'clock position. That's where the North Pole is, that little dot right over there. All right, on this slide right here, the green and blue regions show where the atmosphere is clear. As you can see, there are some parts of the atmosphere that is actually clear. The yellow and gray regions, a hazy cloud layer is reflecting the sunlight away. Yeah. Of course, just above the surface of Uranus, lies the troposphere. Right above. The troposphere is the very, very top part of the atmosphere. The winds of Uranus can blow about 560 miles an hour or 900 kilometers per hour, in case anybody here doesn't do the metric system or not. When the NASA Space Telescope did the infrared camera and multi-optic spectrometer, they also got the very distinct clouds, and they realized that it's 82% molecular hydrogen, 15% helium, and just 2.3% methane. Yeah, I said methane, not methane. In 2008, observations made at the Keck Observatory again, Hawaii, shows the outer rings of Uranus. they're both colored blue and white in the images. Like I said, it has 13 known rings, using a narrow and a dark, and the outer rings are brightly colored, as you can see. Of course, maybe it'll ask, how did Uranus have on the side? Well, about 3.5 billion years ago, there was something that scientists called the Late Heavy Bombardment. It's when everything within the outer solar system came crashing in toward the inner solar system, which means all the force and other planets basically had had Uranus and Neptune switch places. So this is why they are in the current locations right now. And I'm going to get into that in just a moment. See, right now, the current axis of the different planets, from Mercury all the way up to Neptune, they're all at a tilted angle except for Uranus, 98 degrees flat. See, this simulation right here, it shows the most likely Uranus impact. You can see the new brightly colored detailed simulation. It feels like a huge planetary body just crashing into the planet itself. And this other simulation right here, closer colored one, make it a little bit easier for you to see in case you want to have a little spectral or color situation. It was like a grazing collision, not a deep impact, just a grazing collision. Basically, it'll end up it scattered a thin layer of hot outer shell near the edge of Uranus, the ice layer. Underneath, the hydrogen and the helium atmosphere was basically all dispersed. And like I said, like all other planets in the solar system, Uranus has moons. How many again? 27. Yep. Unlike other Roman and Greek gods, these moons are named after William Shakespeare and Alexander Pope. They are divided into 3 different regions. There are 13 inner moons, 5 major moons, and 9 irregular moons. An irregular moon means it's not totally spherical. Just like Miranda, it's a hodgepodge moon. That's what scientists basically call it, a hodgepodge. Why is it called a hodgepodge? It's basically crushed up in different tectonic interactions, different plates. You can see the striations for the lines. It's about 471.6 kilometers around. It takes about 1.5 days to orbit Uranus in itself, and it's very cold, minus 213 degrees Celsius. Not Fahrenheit, Celsius. That is freaking cold. Of course, Miranda reveals complex geological history, as you can see in Voyager 2 image. You can see the striations right here. Miranda's surface is almost as bright as that of Ariel, but none of them reflect more than about 1/3 of the sunlight that strikes them, which means that Miranda is an icy body surface. Yes. Ariel. It was discovered on October 24th, 1851 by William Lassell. It's a medium-sized planet, medium-sized moon. It's about 368 miles radius across. And it orbits at 118,000 miles away from Uranus itself. Our moon is about 325,000 miles, so it's kind of a little bit close in. It takes about 40 hours to complete one full orbit around the planet. So 2 Earth days, you got one whole entire Ariel, or Ariel, however you want to pronounce it. And like Miranda, it's cold, 213 degrees minus Celsius. There's another moon that Uranus has. It's called Oberon. And if you're wondering about Oberon, it's an estimated about 473 miles across, and it's actually the furthest from the planet of Uranus. But it takes actually more than 13 days to orbit the planet here. Just like many of the outer body planets, Oberon does have a lot of craters. It has more than any other moon planet that orbits Uranus at this time, according to the Voyager 2 and the I can't talk today. According to Voyager 2 probes and the New Horizon, they so far discovered that Oberon has the most craters for Uranus. Of course, the core makes up 63% of the whole entire moon, and it's named after the Shakespearean character Hamlet. So we're far without Hamlet. Wrong play. I know. And speaking of another William Shakespeare play, Puck. Yeah. It was discovered in December of 1985 by Voyager 2. It's one of the smallest moons of Uranus. It's only about 90 miles across. It orbits in less than one whole day. Yeah. The thing about Puck is it's between the rings of Uranus and Miranda. Like I said, there are ring systems here. Titania. Yep, Titania. It was discovered on January 11th, 1787 by British astronomer William Herschel. He is a great British astronomer. If you need to look up some history, I would suggest looking up William Herschel. Spelled Herschel. Titania it's about 1,000 miles across, and it orbits about 436,000 kilometers, which is 271,000 miles. Just shy of our little moon to Earth ratio here. It's also the second farthest moons among Uranus itself. And as you can see, on the right-hand side of the moon, there are fault lines. Yeah, fault lines. Voyager 2 discovered fault lines in Uranus and moon. The other bright spots you see distinguished by radiating rays. This has probably created halo marks that create more recent impacts. Let's see. These two features indicate right here on the side of the moon itself. It's about 1,000-mile long diameter. Yeah, and it's about 6 mile wide. Yeah, talk about the big Grand Canyon. Here's a better clear picture over here with a low angle illumination. It shows actually the shape of the surface, which is very clear. And at least two directions of faultings are visible. And something else about Titania, it has the largest known crater on the surface. It was named Gertrude. It's about 326 kilometers in diameter, of course. It only takes about 8.7 days to complete one full orbit of Uranus. Neptune. Yep, we're done with Uranus and its planetary system. Neptune. But before we go, let's see. We got Neptune right here. Duh. This picture was produced from the last image taken through the green and orange filters of Voyager 2, the narrow angle camera. They were taken about a 4.4 million range away from the planets, 4 days and 20 hours before its closest approach. And as you can see in the middle, the great black dark spot right there is a smudge. It's about the size of a red spot on Jupiter. North of these are the bright clouds similar to the one south of the polar streak, as you can actually see on the right-hand side of the picture. Before we actually continue on, we're going to take a quick commercial break here, and we'll be back shortly.
Hey guys, LDG Pixels here. You have issues with your computers, have any IT questions? Come join us at YouTube at LDG Pixels. That's on YouTube, LDG space Pixels. I'm live. I'm here to help. Tech news, nerd chat, help you fix up your computer free.
And we are back. We are still discussing Neptune here. Neptune. If I can get this thing to work. Neptune. It was the first planet not to be discovered by a telescope, but through mathematical calculations. Yes, math works, people. It was discovered in 1910 by Johann Gottfried Galilei. Yeah, that's how you pronounce it correct. It's correct pronunciation. He helped actually. He used the calculations from Urbain Lee Viers to help find it where it was. It was not after the mathematical calculations that made the region of Uranus and Neptune was actually first to be seen, and it actually made Neptune now, according to 1910, the farthest planet from the sun. Yes, I said 1910 because we're going to get into that in a second. Neptune is 2.8 billion miles from the sun and takes about 164 years to orbit the sun, which means since its discovery, it has made an orbit. A day on Neptune is similar to about 16 hours, 6 minutes, and 36 seconds. These are the exact measurements from NASA. 16 hours, 6 minutes, and 36 seconds for a complete rotation. One whole day. It's about 15,299 miles across, and it travels at about 12,253 miles per hour through space. Our orbit around the sun is about 67,000 miles per hour, so it's a little slow. Except the things that's not slow are the winds. Yep, they have a slow orbit, but it has the fastest winds in the solar system at an average speed of 850 miles per hour. Yep, that's pretty fast. That's faster than any hurricane on this planet. I got this diagram here. It shows the color contrast. They're actually modified to emphasize the planet's atmospheric features. You can see the great dark spot stands out most as the most prominent feature on the left-hand side of the picture. The purple is the most fastest, along with the light magenta, the pink, the green, from pink, yellow to green as the speeds go. This picture right here was taken by Voyager 2 using the amateur imaging processor. Love this picture of Voyager. You can see the high striations in the cloud. Just totally love this picture. Another picture from Voyager 2 was the high-resolution color image. This was actually taken 2 hours from the closest approach. The winds, like I said, it can blow up to 580 miles an hour, which I will calculate for you guys in metrics. 2,400 kilometers per hour. Okay, I did my math. I even put it on there. I'm not a complete lazy American. We need to use the metric system sometimes, like football. Of course, the inside of Neptune is a little bit different than Saturn itself, and different than Uranus because they have a little thin upper atmosphere. The atmosphere is made of hydrogen, helium, and methane gas. And there's a very thick mantle, which is made up of water, ammonia, and methane ices. How can water be the mantle? Well, it's so compact and frozen, it makes a solid object. But of course, Neptune does have a solid rocky core in the center. Like I said, there are 6 rings in Neptune, and they are probably named. The ring number 1 is the closest one inside. It's called the Galilei ring. Ring 2 is called, the thick blue line is called the Leverrier. I hope I'm pronouncing the French name correctly. Ring 3, which is the blue one inside, is the Lassell. The white one on the outside of the blue is called the Arago. Of course, the 5th one has yet to be renamed. I even looked at NASA this morning to see if they actually have an official a name for the 5th ring of Uranus, and there is not yet. So, time to put your submissions in. Hey, my name's up for grabs. Of course, the most outer ring we have is the Adams ring. And that is actually the plane of that is actually, when we look on Uranus, this is actually what we see. Unlike Saturn, it's not flat on. We can actually see the rings. It's one of the most detailed ring systems we can actually see. As you can see, you have several different moons encamping the rings. You got Naiad, Thalassia, Despina, Galatea, Larissa, and Hippocamp. Yes, we are done with the planets of our solar system. We have explored Mercury. We have explored Venus. We have even talked a little about our own home planet, Earth. We have explored a bit of Mars. We have talked about Jupiter, Saturn, Uranus, and Neptune. And now where does that leave us? We leave us in the Kuiper belt, outside of our own planet system. There's been Voyager 1 and Voyager 2, Pioneer 10 and 11, and the New Horizons mission. These are the only probes that actually left our planetary solar system into the Kuiper belt. The Kuiper belt is not to be confused with the Oort cloud. It's basically a whole bunch of rings of, it's a ring system of icy bodies of comet-sized projectiles. It's occasionally called the Edgeworth Kuiper belt, but most people call it the Kuiper belt, spelled Kuiper. It extends about 30 AUs out from Neptune and about 50 AUs out from the sun. AU means astronomical unit. It's similar to the asteroid belt itself between Mars and Saturn, Mars and Jupiter, but it's way larger. It's 20 times as wider and 2 to 200 times as massive. Like I said, it shouldn't be confused with the Oort cloud, which is more distant region of the space. It's where all the comets hide out. Of course, our exploration would not have been possible in the Kuiper belt without Clyde Tombaugh. Yes, I have to mention Clyde Tombaugh. He discovered Pluto in 1930. He was born February 4th, 1906, and he died January 17th, 1997. He did not live long enough to see New Horizons, visit Pluto, but some of his ashes are on the New Horizons probe. Yes, they are. His family wanted to make sure he visited Pluto when New Horizons did. This is basically what Tom saw when he looked through his telescope. And you're wondering, what is this? Well, that's Pluto. Yeah, we didn't have a clear picture of the planets for a long time. 2010, Hubble tried to do a composite picture. And of course, this is the best we can come up with until New Horizons flew by in 2015. This was taken 7,800 miles from Pluto's surface. You can see it has a big old giant heart saying, hello, we love you, Earth. Everybody loves the heart of Pluto. There's a little digital animation here. You can see what Clyde saw, as you can see. And as different approaches through the Hubble telescope, beginning in the 1990s, and when New Horizons finally approached it, the Pluto itself, you can see it zoomed in on the surface, the mountains, the craters. This actually here is from the Lowell Observatory. This is Tom Kleibaugh's picture from his blink comparator. If nobody's familiar with what a blink comparator is, it's a huge round plate with little holes in it, and each one is an actual photograph. What astronomers used to do before computers was to match up these different plates and see if there's any movement in the stars or any movement in the background. If it's stationary, it'd be a star. If it's a movement, it'd be an object. As you can see, he detected on January 23rd, his very first picture. He took a picture a week later on the 29th, and the object moved. Discovery of an object. But what he didn't realize when he discovered Pluto, it has an elliptical orbit. Elliptical orbit means you have the stationary sun, everything orbits around it perfectly fine. Not Pluto. Pluto does this. It has a very odd orbit. The New Horizons probe is one of the best engineering by Johns Hopkins. It was launched January 19th, 2006. It made its first Pluto flyby on July 14th, 2015. And on July 1st, 2019, MU-69 flyby. What is MU-69? Well, I'm going to talk about MU-69 in just a few moments, but look at this. Let's check out this little New Horizons probe right here. It has several different instruments. It has the SDC, which is right underneath the spacecraft, which is the Student Dust Counter. It was built and operated by students itself. Yeah, actual high school students put an instrument on a spacecraft. Yeah, and there's also the Pepsi. Nope, not a drink. The Pepsi is the Pluto Energetic Particle Spectrometer science investigation. Yep. This is what helped sniff Pluto's atmosphere. It's basically like its little nose. And when Pluto launched, it started the exploration of our ends of our solar system. And when it approached Ultima Thule, Professor Dr. Brian May gave a special presentation to the world.
T-minus 15 seconds.
Ready? Roger.
15 seconds. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff of NASA's New Horizons spacecraft.
The revelations of New Horizons may help us to understand better how our solar system was formed.
To explore.
Such a beautiful song. Thank you, Dr. Brian May, for contributing this song to the world for New Horizons. As we just saw, New Horizons just explored Pluto. Very dramatic pictures they took. This is the New Horizons lower image of Pluto. The first picture was taken April 15th, 2015, at about 67 million miles away. The second picture was taken about a month later at 47 million miles away. As you can see, we still have very fuzzy images of Pluto. When New Horizons arrived, this geological map, it only covers about 1,290 miles of the surface itself, a little bit of the heart. You can see it's a huge plane and discovered as nitrogen ice plain. It was called Sputnik Planum. I think I pronounced that correctly. Sputnik Planum. Like I said, Pluto's orbit around the sun. It's very elliptical, and it takes 248 years to orbit in a less circular motion, like an egg-shaped, other than the other planets. So see on the bottom graph. This picture right here was taken by Hubble. You can see some of the moons nearby. Pluto and Charon. Charon. I believe it's pronounced Charon. If I'm mispronouncing the name, please let me know. You can also see Nix and Hydra, but you don't see Styx. In 2006, Pluto was reclassified from a planet to a dwarf planet. Yep, it's no longer a planet. But it does have 5 known moons, like I said. Charon, Nix, Hydra, and Styx. The latter 2 moons are not big. There's also 2 other little moons called 211, 1343401, and S-2012, otherwise known as 1343401. Those 2 have not given names yet. The word Plutoid is mainly thrown around. It's used to classify an object that is not rounded in orbit at the sun's distance further away than Neptune. Currently, there are 4 Plutoids that I actually recognize: Pluto, Eris, Haumea, and Makemake. I didn't say Makey, I said Makemake. Maki. That's a Hawaiian word. Of course, some astronomers do believe there's more than 70 more objects out there to be waiting to be classified. When New Horizons visited Pluto, they found out it's made up 50 to 70% rock and about 30 to 50% of it ice by mass. It's supposed to have a rocky core surrounded by a water mantle of ice with frozen nitrogen. Yep, frozen nitrogen. And the core is only supposed to be about 1,000 miles wide, which is about 70% of the total diameter of Pluto. If Pluto and Charon was superimposed upon America, this is actually how big they would be. And a person would only weigh 1/5 of what they would weigh on Earth if they were standing on Pluto. And about 1/24 they would weigh on Charon. I forgot to put that in there, but I gave you the information anyway. Pluto is basically the minimum, since it's such an elliptical orbit. The closest it will approach Earth is 2.8 billion miles, and the farthest away to approach is 4.6 billion miles. Yeah, Pluto is still cold. It's about minus 396 to 360 degrees Fahrenheit. Yeah, that's a nice little ice cube there. Like I said, Charon or Charon, have you pronounced it correctly? It is Pluto's little satellite sister moon. Yes, you can see it looks a little scrunched up because the top layers have been bombarded by craters as well as the bottom. Charon was not discovered until 1978 by Jim Christie. Yes, this is the famed astronomer Jim Christie. Another person to look up if you want to do some research on astronomy and astrophysics. What he's holding up is the actual images of what he first saw. And Charon, on the right side of this picture, is that little bulb on the left-hand side, and the other picture is on the bottom side. That is Charon. What's on the screen is the New Horizons picture that he actually got a chance to see. This right here is actual New Horizons images of Pluto and Charon. Yeah, like I said, Pluto and Charon are very differently. Pluto, basically, Charon does not orbit around Pluto. Pluto does not orbit around Charon. They orbit around each other. Yeah, in an invisible space, a point in space. It's a binary planetary system with the moon there. It takes about 6.5 Earth days for Charon to run over to Pluto, and unlike Uranus, Charon is just like Charon is on the side. Another one of our weird planetary bodies. It's almost half the size of Pluto. The reddish brown part you see in the image right there, it is the cap of the North Pole of Charon. It's composed of tholins, organic macromolecules, of course, that may be essential for life. What is an organic macromolecule? It's the chemicals that scientists use to create the black substance when they create life, the amino acids, that sort of stuff. The tholins, basically, they're saying it was produced from methane, nitrogen, and related gases released from Pluto's atmosphere, as it circumvents itself. So, gotta ask a question. What did New Horizons see when it was about 120,000 miles away from Pluto? Did it take a look at the Earth? Well, it could have, but it actually saw this. And this stunned astronomers and actually stunned me. Yeah, I got shocked because I did not expect to see something like this on Pluto. What is this? It's an atmosphere. Yep, Pluto has an atmosphere. The farthest object we actually discovered here before the 1950s has an atmosphere, yes. But it's a very, very thin atmosphere. It collapses when it moves closer. Like I said, it has an elliptical orbit. When it's close to the sun, it freezes and collapses back onto the planet. But when it goes farther away, the molecule nitrogens and the carbon monoxide regas and forms a small little atmosphere around the planet. Don't try to breathe. It's very, very small. This is a Plutonian landscape in twilight under a haze sky. And yes, this is an actual picture. New Horizons. This is some of New Horizons' final views of Pluto. When the New Horizons took pictures of Pluto using a spectrometer, they zoomed in on the image on the planet, and they found some odd little striations. It's called craters and the ice mountains. Pluto is a little bit active. Yeah. As you can see, a little bar on the side. That bar represents 10 miles distance of Pluto itself. So these huge mountains and rocks are over 10 miles long. And if you actually go into Earth, this is not Earth. This is Pluto. Yes, it looks like the ice sheets that are around the Arctic on the Earth. This is why they say Pluto is active. Come on. Like I said before, why is Pluto no longer called a planet? Well, blame these guys right here in this picture. This happened on August 24th, 2006. This is why Pluto is no longer a planet. But hey, don't blame this guy. Neil deGrasse Tyson had nothing to do with it. Please leave Dr. Tyson alone. He had nothing to do with declassifying Pluto. It was this man, Mike Brown of Caltech. He's so famed for destroying Pluto as a planet. His official Twitter handle is Pluto Killer. Yes, you can follow Mike Brown. He's very cool astrophysicist at Caltech, Cal Institute of Technology. Pluto Killer is his Twitter handle. He is most famous for saying, quote, "So hey, Pluto's still not a planet. Actually never was. We just misunderstood it for 50 years. Now we know better. Nostalgia for Pluto is not really a very good planet argument, but that's basically all there is. Now let's get on with reality." Yep, that's Mike Brown, the official Pluto Killer. So please, leave Dr. Tyson alone. The IEU in 2006 came up with what exactly is defined as a planet. There's 3 different classifications. A planet is a celestial body that orbits around the sun, has enough gravity, it makes its own little self, and clears the neighborhood around its orbit. A dwarf planet is a small celestial body that does not clear its orbit around the planet and is not a satellite of any other solar object. All other objects except satellites orbiting the sun shall be referred to as collectively as small solar system bodies. And they came up with Resolution 6A, definition of Pluto-class objects. Pluto is a dwarf planet. So, how can something be called a planet, which is not a planet, called a dwarf planet? What the IEAU did not take in consideration, since the orbit of Pluto is so far, they have not been able to detect if Pluto actually clears its debris from its surrounding orbit. They have not accounted that. They only surmise that it does not, but it has been no circumstantial evidence that it does or does not clear its orbiting debris around its orbit around the sun. Until they have done that, it's still classified as a dwarf planet. Yep. And these are some of the dwarf planets, Plutoids, moons: Styx, Nix, Kerbos, Hydra, and of course the largest one is Charon on the bottom. As you can see, Nix is supposed to be about 26 miles long and about 36 miles wide. Yeah, it's huge. Hydra on the right-hand side is just a little bit small with about 0.7 miles wide and about 34 miles high. Yeah, small little moons there. We are going to talk about Kuiper Belt objects. Yes, more Kuiper Belt objects. But we're going to do that. We are going to take a quick commercial break and be right back.
Hey, what's happening? This is Kornemic, and I'm talking to you from my backyard. Just signed up for Cameo app, and Sean asked and told me that's what all the cool kids are doing. So I'm just trying to be one of the cool kids. But I am dedicated to this. Dedicated to leaving you a message, no matter what the conditions are. That's why I'm doing this in the rain, to prove to you how serious I am about this. I mean, I will give you a shout out from a train, you know. I'll give a shout out to you while I'm on a plane. I'll give a shout out to you from a car. I'll give a shout out to you from a dive bar. In fact, I heard that David Faustino's on here as well. He said that he was gonna give some weird and creepy shout outs, but I challenge him. You want a weird and creepy shout out? Came to the right place, buddy.
Here, so we're talking my way out there. More Kuiper Belt objects. Yep, we're going to be talking about more Kuiper Belt objects. For instance, there is Eris. This is an actual picture of Eris. It was discovered in 2003, and it's mostly likely composed of frozen water, ice, and methane. Yes, I did say frozen water, ice. Yes, there is frozen water in space. It's just a little bit bigger than Pluto, but its orbit is twice as distant from the sun, of course. And like Pluto, it does have one moon, as you can see on the right-hand side of the picture. It's called officially 136199 Eris 1 Disamia. Yep. Try saying that 5 times fast drunk. It's only about 1,134 kilometers around big. Its surface temperature is minus 239 degrees Celsius, and it takes about 310 years to orbit the sun. It was discovered on March 31st, 2005 by Michael Brown, Chad Trujillo, and David Rabinowitz. I mispronounced your name. I apologize for you 3 astronomers. I always give credit to the astronomers who discover stuff. And like I said, this is not makey-make. This is not make-make. This is make-make. Another Kuiper Belt object. It takes about 310 years to orbit the Earth, which is about 113,150 Earth days, in case you wanted to actually do the mathematical calculations. It's about 4,253,000,000 miles away from the sun itself. And scientists believe that the cold surface is made of methane, ethane, and nitrogen ice into ices. It's so cold, it's minus 143 degrees Celsius. Damn, it's cold out in space. I mean, with the radius of approximately 444 miles across, it's only about 1/9 the size of Earth. And if Earth was a nickel, Makemake would be about the size of a mustard seed. It's about the size of Makemake. And on April 2016, Makemake has a moon. Yep, Hubble looked at Makemake, and they spotted a moon 20,000 kilometers away. It's only thought to be only the 4 outer dwarf planets not to have any moons. They were wrong. See, discovery leads to great amazing things. We also have another Kuiper Belt object called Haumea, which is right in the center of the picture. I hope I'm not pronouncing this incorrectly. And it also has 2 different moons. Hyakea is above, and Namaka is below. I can pronounce Namaka. One of the things about this interesting little body is that it rotates. Yep. Normally when something rotating in space, it'll go to a solid little object right here into a circle. But it rotates so quickly, it's distorted into an egg shape. Due to its fast rotation, only a day lasts about 4 hours. Yeah, but it does take 285 years to orbit around the sun. It was discovered in 2004, led by a team of astronomers led by Mike Brown. Yes, that Mike Brown. I told you, astronomers rock. Astrophysicists rocked. Follow Mike Brown on Twitter, Pluto Killer. It's not that big. It's about 385 miles across, and it's only about 1/114th the size of Earth. Sorry, there is something on the far left of Hamas itself. You see it right there. 3 Hamases can fit easily side by side into Earth. Sorry about that. Next part. Discovered in 2017, Hamas actually has a ring. I'm getting ahead of myself about the next part, but yeah, Hamas has a ring. It's not a gas giant with a ring. It's a solitary body with a ring. This is the other solitary body that has a ring in our solar system. Of course, it's approximately 40 miles wide with an opacity of 0.05, which means it's very, very thin. Almost as thin as Uranus's ring system. The ring particle makes about 1 rotation every 3 times Haumea rotates. So every time it rotates, the rings go around once. And it's the only known dwarf planet to have a ring. Like he also said, you have a ring, like it, put a ring around it. This is AU-65, otherwise known as Erich. MU-69, Ultima Thule. That's another common name. People will recognize that as Ultima Thule. Because the news is talking about Ultima Thule, Ultima Thule. This is what Dr. May was talking about when he made a song. But it's officially now called Akaroth. It's very weird, little shaped object here. And you can see a little propeller. It was filmed on January 1st using the LORRI, the Long Range Reconnaissance Imager. Haumea, I still want to call it Ultima Thule, but the Ultima Thule has a radius about 385 miles. As you can see, it's spinning back and forth. The reason why it has 2 different bodies next to it, because it's actually 2 objects into one. Yeah, the huge object is about 22 miles long, and the small object is only 12 miles long. It takes 293 years for Akaroth to make a trip around the Earth. The reason why people are saying scientists believe it's student objects is because it's called accretion. Astronaut Mr. Love in the middle 90s did an experiment above the International Space Station. He had some salt. I should post that video for you. He has some salt and some water, and he shook the bag. And you can see the tiny little particles electromagnetically pull to each other. That's the example of accretion. This is what actually scientists believe what is going on here compared to that thin little ring around the bottleneck of the snowman. Accretion at its finest. Of course, when was it discovered? June 26, 2014, by this man. This is Mark Boy, another astrophysicist that I would suggest you follow. Some great astrophysicists here. And for anybody who has 3D glasses, you can use 3D glasses to look at the 3-dimensional shape of this picture right here. I found this online thanks to NASA. They created some multispectral images, so anyone with 3D glasses can enjoy Ultima Thule. Yes, I did call it Ultima Thule. There is a suspected planet 9 in our solar system that scientists have yet to detect. People believe it's an icy object. Some other scientists believe that it's a mini black hole. Nobody actually knows what this thing is. Hey there, I hope everybody enjoyed a little tour of the solar system. We went all throughout the system right here. We did our own little planetary system. Oops, wrong little button here. Next week, since we talked about our planets, we are going to be talking about exoplanets next week. Yeah, there really are exoplanets outside our own solar system. So hope you tune in next week. That little subscribe button, I suggest you do it now. That way you kind of get the little notifications of when I'm going to go live or when I decide to post a video, because you never know what's going to happen. Science happens every single day, every single week. New things happen, new discoveries happen. Like, for instance, you can see Mars at its closest tonight and tomorrow night. All you got to do is look up. Look next to the moon. There's Mars. So I want to thank everybody for being here today. And have a good day. Have a good evening, everybody. Thank you.